I gave you two graphing ones in terms of one standard, one in what form? Yeah, vertex. So we have standard form, and then we have vertex form. So what was the vertex in number 1? Yeah, Anton. Good. -1, -9. Again, how do we find the vertex? Is -b over 2a, and that's how we get -1. In order to find y, substitute -1 in to find y. So we have 1 minus 2 minus 8, and that's how we get the -9. Okay. What is the y-intercept? Good. 0, -8. So we have -1, -9. Okay. And 0, -8. We also know that we have -2, -8 because it's symmetrical. Anyone find our x-intercepts?
-4, 0, and 2, 0.
Good. And how'd you get that? Okay. -4, 0, and 2, 0. Anyone find those a different way? Yeah, Jonah. You could factor as well, okay, which we will talk about today. But if you did your table of values, you're good too. Here, we could factor. So x plus 4 and x minus 2. In order to find the x-intercepts, we set equal to 0. So we have x equals -4 and x equals +2, which would be our two x-intercepts. Okay, good. All right. And one thing I did not add, what is the domain? -infinity to infinity. What would be our range? -9 to infinity. Okay, so our domain and range of that function. How many of you did get number 1 correct? Okay. Number 2 is in vertex form. What is our vertex? Yeah. Good. -1, 4 is the opposite. Each value of what you see. So -1, 4. Okay. What was our y-intercept? Yeah. 3. So our y-intercept is 0, 3. So if we know 0, 3, we also know -2, 3. And it should be facing down because why? Yep. Yep. Okay. Anytime for a y-intercept, you substitute x equals 0. So we have 0 plus 1 squared plus 4. Then 0 plus 1 is 1. It's 4. 1 squared, you have to take care of your exponent first. 1 squared is 1 times -1. -1 plus 4 gives you 3. Okay? All right. Now it should be pointing down because our leading coefficient is negative. Okay? The number in front is negative. As opposed to here, it was positive, so that's why I pointed it up. Did we find our x-intercepts at all? Yeah, Mike.
-3 and 4. -3, 0.
How'd you get it?
I just put in a line, so I just plugged in -1.
Okay. All right, that's okay. You could use your table of values, okay, the 5 that we chose, 2 to the left and 2 to the right to find it. Can we also solve this? Yeah, okay, which another topic we are getting in today, where if for x-intercepts, no matter what, you have to set your y equal to 0, okay? What do you do here? Yeah, Anton. Okay, equals -4, then what do we have to do first? Yeah, man. Divide by -1. Okay, then what do we do? Yeah. Square root both sides. And since we're solving, okay, since we are solving, We have x plus 1 equals 2. X plus 1 equals negative 2. You have two solutions. So when you take the square root of either side, you have x plus 1 equals 2, x plus 1 equals negative 2, and that's how we get 1 and negative 3. Okay? What would be the domain of this function? Okay, the same for all. And what would be the range? Bracket. Okay? It's amazing. I just went through that and I saw no pencils being used at all for solving. Just saying. Solving or even domain and range. How would I factor it? Yeah. Okay. 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 So one thing that I will change, which you are correct, it means the same thing. If a negative comes first, we want to pull that negative out with it. Okay? So instead of 2x, we're going to take out the negative 2x, which you are correct. And we have x squared minus 8x plus 16. It makes it a little more easier to deal with because you don't have that negative in front. So we have negative 2x, x minus 4, x minus 4, or negative 2x, x minus 4 squared. Either one is acceptable. Okay, and obviously with that too. But one rule that you will see, when a negative comes first, you want to take that negative out. Okay. How about number 4? Julia? Mm-hmm. Okay. Good. And here we are just factoring completely. Okay, both of these we're factoring completely. So we're not solving here, just as is. So you have your negative 3x, then you have the difference of two squares, which is x squared minus 25. You can keep going to x minus 5 and x plus 5. Okay. All right, and the last one is a piecewise function. Okay. How do we start? What do we do? Yeah, Liz.
Well, first I wrote out next to it like the interval notation,
Mm-hmm.
each one,
Mm-hmm.
and then there I would plug in. So for the first one, I plugged in numbers that were less than 2,
Mm-hmm.
and then for the second one, I plugged in numbers that were 2 or greater.
Okay. Okay.
I just didn't know. Was it okay if I plugged in for the first one? Would it be okay if I plugged in 2?
Yes. Mm-hmm. You could. It's just the difference of the point. That's it. Yeah, and that's where I want you to start, actually. So that's a great point. Whatever's in your domain, that is starting off your graph, okay? So even if it's not included, that just means the circle is going to be open. That's it. So we have our first point at 2, 7, okay? So I substitute 2 in. This is going to be an open circle at 2, 7. Okay, and it's everything to the left of 2. So I could plug in 1, I could plug in 0, negative 1, okay, so 0, 5. So this is where the graph is heading, okay, this line, just this first one. Then we're going to do the same thing with the other one, okay, however, we're plugging 2 in. 2 times negative 2, negative 4, minus 1 is what? Okay, will that be open or closed? Closed, okay. 2, -5. Okay. Now I could choose x values that are larger than 2 or also apply the slope. So if I choose 3, -2 times 3 is -6, minus 1, -7, so 3, -7, and I could keep going. Okay, here is the graph. Right, this is what you should have. So what would be my domain? Yeah. Good. What would be my range? Yep. Negative infinity, 7, good. And how would I write it? Good. Okay. Is this a function? Yes, it is. Okay. F of 3, what would it be? Yeah, Jonah. -7, good. F of -4 would be what? Liz? Careful. -4 plus 5. 1. It's okay. F of 2, we already know, would be? -5. Good. All right. So looking at everything, okay, that was on the warm-up, and it's a little bit of everything, okay? The quadratics was one in terms of graphing, some factoring, which we're going to see today, and piecewise. How are we feeling for the first two? It's kind of shaky a little bit, some of you, okay? Factoring. Good, okay? Piecewise. Okay? Just knowing that whatever's in your domain given to you, you could rewrite it in interval notation, which we see here, substitute that value in to see where your starting point is. Okay? That shows you your starting point. You know when it's going to be open or close, then you use additional values to see the direction of your line. Okay? Any questions? Okay. Today, actually take out your current packets. Current packets that we have. Okay. All right. Current packets, and we skipped over a few. All right. We skipped over these guys. Okay. Yep. Here you go. You're welcome. We're on page 6. Okay. All right. So we are creating equations, okay, based off a graph in vertex form. However, we could figure out the vertex, but we need to find that leading coefficient, okay? So when you are given a graph, as you see here, you know what the vertex is, which is the lowest or highest point. What is the vertex in this first graph? Okay, so we have 0, 3, okay, is our vertex. So if I was to write that first in vertex form, this is what it would look like. Y equals, I don't know that A value, okay, x minus 0 squared plus 3. Okay, and I put that in for a reason. Okay. X minus 0 squared plus 3. Now, I could get rid of that x minus 0 to have x squared plus 3. Okay. Now, since we need to find a leading coefficient, you choose a definite point on the graph, not the y-intercept, but typically that would be a good point to use. So you look at the graph and see where there's a definite value. So if you look at 2, you could either do 1, 4, okay, or which we're going to choose altogether, 2, 7, okay. 2, 7 looks like a definite point, okay. So since we know a point 2, 7, we're going to use that in our equation in order to find A. Okay? So we have 7 equals A we're trying to find 2 squared plus 3. Okay? We want to solve for A. So we have 7 equals 4A plus 3. What's the first thing we have to do? Yep. Subtract 3. So we have 4 equals 4A, and then what? Divide by 4, which is 1. So here, looking at it, right, using 2, 7, our A value is 1. Okay, so our equation, and again, that could change. This just started off of how to find A. So we have y equals x squared plus 3 as our equation. Because the A value is just 1. We do not have to include it here. But it should be positive because why? Why should this A value be positive, Jonah? It's pointing upward. So if I look at the next one, okay, my A value should come out as what? Negative, okay? So let's first start with the vertex, okay? What is the vertex? Julia, what do you have for the vertex? Let's see. So 1, 2, 3, 1, 2. Okay. So the vertex is 3, 2. Okay. The easiest point to choose would be what? One of the x-intercepts. Okay. One of the x-intercepts. So let's choose, it doesn't matter which one. Some of you could choose 2, 0. The other could choose 4, 0. Okay. So let's look at this. So we have y equals a times x minus 3 squared plus 2. That's the shell of our equation. Okay. Now we're going to substitute in one of the x-intercepts. So we have 0 equals a times 2 minus 3 squared plus 2. What does a equal? Negative 2. So our equation in vertex form is negative 2 x minus 3 squared plus 2. That would be our final equation. Okay, so no matter what, from here on out, anytime you're writing an equation for a function, in this case quadratics, you are going to find an A value. Okay, but in order to do that, you have to pick a point, a definite point on the graph. Does that make sense? Okay, so this was vertex form. Okay, to find the equation in vertex form, if you turn to, oops, this page here. Okay, we are using intercept form now. Okay, we are finding intercept form. So who could tell me what are my two intercepts right here? Go ahead. Okay, so we have negative 6, 0 and 4, 0. Okay, so now this is the shell of our equation. Okay, we need to pick a point. Okay, I'm sorry the graphs are a little grainy looking at it. What point should we choose? What do you guys think? Yeah. the y-intercept we could choose, which is 0, 0, -8. Okay. So let's try. Yeah. Careful. Careful, careful. We have -8, -24. Okay. Dividing by -24. So -8 divided by -24 will give me 1/3. Okay. Your A is 1/3. So your equation, 1/3 x plus 6 is x minus 4. Okay. Try the next one in your room. Yeah, John. No. Okay. Typically no, unless something changes. Okay. Did you guys get 2/3? Okay, 2/3 for your A value. So we have y equals 2/3 x minus 7 as our equation. Okay, so if you had x minus 0 as your x-intercept, we could just drop the 0 and just add the x. Okay, any questions about finding equations or writing equations? Okay. Right. How can we tell if a graph is opening up or opening down? Yeah. Whether A is positive or negative. How many forms of quadratics are there? Anton? 3. Who can name one? Yeah, Ellery. Yep. Vertex form, good. Isabel? Standard, Julia? Are you sure? Okay. We have standard, vertex, and okay. All right. Liz? Intercept or factored form. It's okay. It's all right. So we know these 3 forms, okay? Today, we are going to see after lunch how to solve to find our x-intercepts, okay? And when we find our x-intercepts, which are our solutions, which are our zeros, there's a ton of names for x-intercepts, okay? We could determine if there's going to be 1, 2, or no x-intercepts based on a part of the quadratic formula, okay? So we have a lot of solving to do when we get back, right? may head to lunch. All right, let's look at the 4 graphs and 4 equations, okay, that were given. Let's see if we can make any connections, okay? Do we want to match anything anywhere so far? Any matches? Those? 2 is D. Good. All right, so let's get rid of B. Anyone else? Anton? 4 is B. Good. Okay, now before we continue, why was number 2 D? Yeah, Ellery. Perfect. Why was number 4 B? Yeah, Liz. Good. Okay. 6 and -8 for the x-intercepts. Excellent. All right. What else? Yeah, Mike. No. It's okay. Yeah. 1 is C. Okay. 1 is C because the vertex is positive 6, 8, and it's opening up, right? So will it cross the x-axis at all? No. So that's why when the vertex is 6, 8, they're in positive, there's no x-intercepts. So therefore it's C, and 3 was A. Okay, where we could factor this as well to find the x-intercepts. We could also see that the A is positive. We could find the vertex, negative B over 2A. All right, any questions? Okay, so today, and we're just going to get to solving today. Okay, today is solving quadratics multiple ways. Okay, there is a way you could determine how many solutions there are. Okay. You're welcome. Okay. So one question we want to answer is, when we are solving quadratics, what are you finding on the graph? Yeah, Liz. Okay. Okay. The table of values and the vertex are additional points, right? But when we're solving, so I showed you 2 options on the warm-up. Okay. When we are solving, what are we actually trying to find? Yeah. The x-intercepts. Okay. We are finding the x-intercepts. Okay. When we are solving, we are finding x-intercepts. A few other terms that we use that you will see is zeros, solutions, as well as roots. A lot of those names will come up in the next unit, okay? But x-intercepts and solutions are all interchangeable, mean the same thing, okay? Now, you are only solving when your equation is set equal to 0, okay? Other than that, you either factor, more so just factoring, okay? So there are ways you could have 1 solution, 2, or none, okay? So no solutions is what we actually just saw, or no x-intercepts, is something like this, okay? When it does not cross the x-axis at all. It could cross the y as your y-intercept, but it will not cross the x-axis, okay? one solution or one x-intercept can be one x-intercept that you see on the graph. Here it would just be 6, okay, where it bounces off the x-axis. Okay. And a lot of times we have seen two solutions where it crosses the x-axis twice. Okay. Now, there's ways when we get to the quadratic formula, a piece of the quadratic formula can determine how many solutions there are. Okay? So the piece of the quadratic formula is called the discriminant, which is b squared minus 4ac. That piece can tell us if there's going to be one solution, no solution, or two. Okay? So if your discriminant, b squared minus 4ac, is less than 0, there will be no solutions. Okay? If your discriminant is equal to 0, there would be one solution. If your discriminant is greater than 0, you would have two solutions. Okay? Now, the discriminant, you might get a question that says uses the discriminant to determine how many solutions and not actually find them. Okay? So it's important to note how the discriminant is used. Okay? Less than 0 means none, equal to 0 means 1, and greater than 0 means there's 2. Okay, 2 x-intercepts. So a few ways to solve, okay, it's factoring. But if you notice, in order to find solutions, they're all equal to 0. So looking at number 1, how would I factor that? X squared minus 5x minus 36. How do we factor? No one knows. Yep.
Multiply negative 36 and x squared.
Mm-hmm.
Negative 5x squared multiplies negative 36 x squared and adds.
Okay. What is it? Yeah. Negative 9 and 4. So how would I write it in factored form? What multiplies to negative 36? No, because we're taking, in terms of factoring, there's nothing new, guys. Nothing new. Just because it's set equal to 0, nothing new. So what multiplies to negative 36, and Isabel's right, like when there is an a value other than 1, I would then do the a times c. Okay, but for these types, you should know what multiplies to negative 36 and adds to 5. Without a doubt, without making a box, without making a diamond, none of that. Without making 4 terms. We should know how to do these. Okay, so like Mia said, negative 9 and 4, which is like this. They're all going to start off the same way. X for each parenthesis, then what multiplies to negative 36 and adds to negative 5. Negative 9 and 4. But now since it's equal to 0, set each equal to 0. And find your solutions. Okay, so you have done this already. Okay, you have done this already. Now we're just solving. And you only solve when it's set equals to 0. Part of your homework the other night was just a factor. There was no solving happening. Okay, so in number 2 is where we are going to apply what Isabel just said. Multiply the a times c. So 3 times negative 8 is what? What multiplies to negative 24 but adds to 10? Careful. Yeah. 12 and negative 2. So 3x squared is 12x. Okay. The last step is setting it equal to 0. So we're replacing the 10x with our two factors. Okay. Split the middle. Greatest common factor of the first two. 3x. What are you left with? Okay. Greatest common factor of the first two. Negative 2. What's left over? Okay. So if you factored correctly, your parentheses match. So I'm going to group together the outside terms in one of the other parentheses. And now for solutions, you just set those both equal to 0. So your two solutions are as follows. Okay, those are your two x-intercepts for that quadratic. Okay, now for number 3, what do you have to do first? Yeah, Julia. Perfect. Good. Okay. Okay. Yeah. Which is? So here, since 5 does not have an x, okay, we're just dividing by 5. So we have x squared minus 4x plus 4 equals 0. Divided by 5. How can I factor? Yeah. So what does x equal? Just 2. And we only have to write it once. Okay. We only have to write it once. Try the last one. Oh, yeah.
Wait.
What?
Well, could you also say, like, since, like, you're dividing by 5, or, like, you're factoring out a 5, could 5 also, like, wouldn't that...
So, and I'm going to show you why. This doesn't have an x, right? But if it did, you would. But if I was to take 5, does that equal 0? No. So since this is, it's a great question because it does come up, okay? Since this is a numerical value, okay, we're not going to have an extra solution. When you do, say if this was 5x we took out, you would then have to set that equal to 0 as well. Okay, does that make sense? Okay, so the difference is, here is a numerical GCF, okay? Here is a monomial because it's one term, but with the x has a variable, so we have to set it equal to 0. Okay? Yep. No, but to make it easier in terms of factoring, it would just mean in the end you would just reduce. That's okay. Yeah. You always want to look for the GCF, especially to just make your factoring that much easier. Yes. Okay. So for number 4, what do they have in common? Anything? 3. 3? Do you agree? Okay. So if we take out a 3, what's left over? Okay. Okay. Now since this is a greatest common factor that's numerical, we can get rid of it. So now we have 2x squared minus x minus 21. Since there's a leading coefficient other than 1, we can now multiply. 2 times negative 21 is what? Negative 42. What multiplies to negative 42 and adds to negative 1? Good. split the middle, x, 2x minus 7. Okay, and we group together. Okay, those are your two solutions. How many of you did get those? Yeah.
Why did you just get rid of 3?
Okay, same thing what Lucy said. This is just a greatest common factor numerical value, right? If it was a greatest common factor that, because if I go back, 5, if I set that equal to 0, can that happen? Does 5 equal to 0? Or, say from here, if I divide by 5, 0 divided by 5 is 0. So it eliminates it no matter what.
Why are there some problems like you have to keep everything?
If it's factoring completely, it's a great question that both of you had. Factoring completely, has to include every single piece. So factoring completely would be 5, x minus 2, x minus 2, or x minus 2 squared, okay? Factoring completely will also mean, say if I had, for example, say if I had this, factoring out of 3, x squared minus 9, that's all factoring completely. Now, if this was solving, okay, if we just took this one step further in terms of solving, I would take each piece with an x to set equal to 0. Because 5 does not equal 0, so I could just drop it. Okay? But if it's solving in terms of, let's do, what is the greatest common factor here? 3x. Okay. What's left over? Okay, can I keep going? Okay. To what? Good. So here, the difference is, everywhere I see an x, I have to set equal to 0. So I would split each of these and do 3x equal to 0. What does x equal? 0. X minus 3 equal to 0. X equals x plus 3, negative 3. Okay, so that's where you include it. So those are great questions that will come up. Both of you said it in your own different way, but both these will come up 100%. And they're right. Like, when do we keep it? When do we drop it? It happens all the time. You keep it always for factoring completely. For factoring, if it's, or solving, sorry, if it's just a numerical value, you could drop it. But if it includes an x, you have to include it. Okay? Yeah, Julia. Yep. Okay. Great questions, you guys. All right. And then the next option is, in terms of solving, is your x-intercepts. To find your x-intercepts is square roots. Anytime you are solving, and this is another thing that we get into, okay? Anytime you are solving by taking square roots, so meaning taking the square root of either side, you will always include plus or minus, okay? So for example, if I had x squared equals 4, there's an equal sign. When I take the square root, my solution will be plus or minus 2. Anytime you are solving by taking a square root, and I could repeat this till I'm blue in the face, you will have to include plus or minus. Okay? So this first one for number 5, and we're solving by square roots, not by factoring. What do you have to do first? Yeah, Lucy. Add 9. Then what? Plus or minus 3. Good. Okay. Number 6 came up on, I think, the piecewise review. Okay. What do you have to do first? add 24, right? Okay, now from here, what do? Square root, okay. So since we're solving, we are going to include plus or minus. Now, this is an area where I'm not sure who learned what, okay? You should have been able to simplify square roots, but again, it could be a split decision. I don't know who learned what, okay? This should have been taught somewhere, okay, this little concept. But in order to simplify square roots, for the square root of 24, think of a perfect square that's a factor of 24. What's the first one that comes to mind? 4. So if I split this, square root of 4, square root of 6, because when you multiply radicals, you can multiply them together. What is the square root of 4? 2. Your final answer would be plus or minus root 6. 2 root 6. Okay? Yeah.
Would I be able to just use my calculator?
No, because it won't be in simplest form. You'll get a decimal. Okay. So I'm glad you brought that up because simplifying square roots will totally come up in this course. Okay. And you will need to know when we get into a different topic of how to simplify. Okay. So just make sure as we go through this, we will practice it. Some of you, it's probably brand new. Okay. I've never seen it before. Or we've used our calculator, right? But now we got to kind of figure out the meaning of how we can simplify that further. All right? All right, let's look at number 7. What do we do first? Okay, keep going all the way through. What do we have to do next? Divide by 3. Then what? Okay, so I just want you guys to go through the process. Can we do this? No. So taking a square root of a negative number at this point, no solution. Taking a square root of a negative number will be no solution. Okay? Looking at number 8, what do you have to do first? Add 50, good. Yeah. And I'm always afraid. What's next? Divide by 2. Okay. It's okay. I'm always afraid to ask it. Then what do we do? Okay. Square root it. Okay. So those of you that like to make more work for yourselves, we don't need to do that. We don't need to expand x plus 3 squared. Because most of you will put, or some of you I should say, x squared plus 9, which is incorrect. Okay. So when you see this, you want to isolate those parentheses squared no matter what, all the way down. Okay. Now from here, we have x plus 3 equals, what is the square root of 25? 5 and negative 5. So you have x plus 3 equals 5, and x plus 3 equals negative 5. So what are your two solutions? Good. Excellent. Okay. Yeah. Okay. You can, however, you have to apply the sign to it. So see how there's two solutions here? So if we had this, most cases I would see plus or minus 2 or plus or minus 8, which is incorrect. Okay, so when you take the square root of 25, you have to break it up into two separate equations. All right, because you need to apply those signs. Right, great question. Any other questions right here? Okay, it's okay. I normally have the thing on it. So. All right. You guys remember this? Maybe? Kind of? One half of you? No? Okay. All right, completing this square gets us into vertex form, okay? It does get us into vertex form, which we just saw by solving square roots in order to solve by square roots, okay? So the idea with completing the square, and we're going to do number 10 first. The idea behind completing the square is you want to isolate your x terms first, okay? So you want to isolate your x terms, and we're going to start with number 10 first for a reason. So here we have x squared minus 12x, okay? No matter what, you'll be adding a different value. When you're completing the square, you're making a perfect square trinomial, which you saw on your factoring practice, which means the x minus 2 squared when you have two of the same thing. Okay, so here, x squared minus 12x plus some number, which we'll get to, we subtract 4 to the other side. So whatever we add to one side, we're adding to the other. Okay, so to find your new c value, which is that, it is b over 2 squared. Okay, that's how you complete the square. So, negative 12 divided by 2 is what? Negative 6. Negative 6 squared. 36. So since I'm adding 36 to this side, I'm also adding 36 to the other. Okay. I'll give you guys a minute to process that. Okay. So we take our b value, which is negative 12. So to find our new c, negative 12 divided by 2 squared, that's how we get 36. Now, how can you factor the left-hand side? X squared minus 12x plus 36. You lose.
Can't you just find two numbers that add up to 12?
Mm-hmm. Okay, what would it be?
-6.
Okay, so I could take this factoring and literally write x minus 6 squared. That's our goal, to make it a perfect square trinomial where you're going to see something that looks like vertex form. Okay, so you're taking your perfect square trinomial and rewriting it as, like Lucy said, negative 6, but instead it's x minus 6 squared. Does that make sense? Now we're back to solving square roots. So what do we do here? Square root it. And since we solved, we have to have the plus or minus. Now, square root of 32. Think of a factor that is a perfect square. Your perfect squares are 1, 4, 9, 16, 25. Yeah. Okay. 4 could be 1. Yep. 16 is another. Okay, so I'm going to show both ways. So with 16, what is the square root of 16? So right now we have x minus 6 equals plus or minus 4 root 2. Our last step x equals 6 plus or minus 4 root 2. We cannot combine those because one has a radical and one does not. So that's how your answer will be. Yep. God bless you.
So you can't put the +6 on the other side of the.
Should always come before the plus or minus radical.
Okay.
Should. Okay. So the other way in terms of simplifying square root of 32, if we used 4 and 8, what is the square root of 4? 2. But now we still have the square root of 8. Can I break that up even further? To what? What's the square root of 4? We multiply 2 times 2, which is exactly what we got on the other side. Okay? Does that make sense? Okay? Any questions? I want you guys to try one. Yeah.
Wait, will it always be like x minus 6 squared? Or will it, like, will always be.
It will either be x minus some number squared or x plus some number squared.
Okay.
Once you complete the square. Okay? So like this one is already done for us. X squared minus 8x plus 16. Can I factor that? To what? Then what do I have to do? Square root. And I have to include what? Okay. What are my two solutions? 9 and -1. Oops. Okay. Good. Yeah, Mike.
So, can you do this with equation?
You could. You could do, if factoring doesn't work, this could be your default. Things will change when we get to 11 and 12, but we're going to save those in terms of factoring because there is going to be a different leading coefficient other than 1. Okay? All right, questions? Questions. All right, you guys did, that was a lot to kind of take in and digest.